All right, so we're starting section 2.4, which deals with the chain rule. And in this video, I'll just go over what the rule says and give two examples that I've already worked out and explain how they were done. And then the next couple of videos, I will be doing example after example, applying the chain rule. So the chain rule is used for when you have a composite function, and a composite function is of the form f of g of x. So it's really a function of another, consisting of another function. And whenever you apply the chain rule, it turns into f prime of g of x times g prime of x. And the way I remember the chain rule is that this f function is what I call the outside function. So f I like to think of that as the outside function, and then g of x is the inside function. So when I take its derivative, it's the derivative of the outside function applied with g of x times the derivative of the inside function applied with just x. So the f prime of g of x portion, that's the derivative of the outside function. The g prime of x, that's the derivative of the inside portion. And that's how I remember it. Derivative of the outside function times derivative of the inside function. Now there's what's called the general power rule, which is really just the chain rule. And it's like our regular power rule. So this is our regular power rule. Derivative with x to the n is n times x to the n minus 1. It's just now I'm using the letter u. And the letter u is going to stand for a function consisting of x. And its derivative of u to the n equals n times u to the n minus 1. So that's identical to what I have over here. It's just this added times u prime part. So this portion where I'm taking the usual power rule, n times u to the n minus 1, that's like the derivative of the outside function. U is the inside function, so times u prime, where u prime is the derivative of the inside function. So this is really writing the chain rule involving the power rule. So for example, consider y equals 2x minus 7 to the third power. Now you could work this problem out by multiplying all this all the way through, and it's going to be a lot more steps than necessary, because if you're doing 2x minus 7 times 2x minus 7 times 2x minus 7, so it's 3 times, and then you're going to get some polynomial, and you can apply the regular rules that we know. But this is going to be less time consuming if you apply this, really the chain rule, but in particular I'm using the general power rule. So I can think of this as y equals u to the third power, where u is this whole thing, 2x minus 7. So the 2x minus 7 is like my inside function. And then the operation of cubing is the outside function. So when I apply this general power rule, you'll get 3 times u to the 3 minus 1. That's those parts. And then times u prime. Now u prime is the derivative of what u is, and u is 2x minus 7. So I take its derivative. U prime will be 2 times 1 plus 0, which is just 2. So u prime is just 2. And so I substitute these in. We have u is 2x minus 7, so I plug that in for u. So it'd be 3 times 2x minus 7, and then squared. So that's 3 minus 1, times u prime, and u prime is 2, so times 2. And then I just do 3 times 2 to get 6. and it'll be 6 times 2x minus 7 squared. And you would keep that as your answer. You don't need to expand this out. All right, that's just an example where I'm using the general power rule, which is really the chain rule. And that took way less steps than doing 2x minus 7 times itself 3 times, and then using the rules that we already know. So I'll make up another one real quick. Let's say I had y equals 4x plus 1 in parentheses, and all of that raised to the second power. All right, and I'm going to use that general power rule, which is really the chain rule, so it's n times u to the n minus 1 times u prime. So in this case, my u part is the 4x plus 1. All right, that's my inside function. So if I take the derivative of the inside function, u prime would be 4 times 1 plus 0. 4 times 1 is 4, and then plus 0 is 4. So the derivative of u is 4. So when I find y equals, I'm just going to substitute, and then it's u squared. So when I find its derivative, y prime, derivative of the outside function would be this part, 2 times u to the 2 minus 1, and then times u prime. So that's going to be y prime's equal to, and then I have u is 4x plus 1. So this would be 2 times 4x plus 1. And then times the derivative of u, which is 4. And then I just do 4 times 2 to get 8. And then times 4x plus 1. And you could expand that if you want. I would just leave it as is. All right, so that's just another example of using that general power rule. My inside function is 4x plus 1. The outside function is the operation of squaring. All right, so the next thing I'm going to show is another application of the chain rule, but doesn't involve this general power rule. So consider y equals sine of 3x. So we know that the derivative of sine of x is cosine x, but in this case I have 3 times x versus just x. In this case, my outside function is going to be the sine operation. And based on this relationship, we know the derivative of sine is cosine. So this is the derivative of the inside portion, or sorry, outside portion. My outside function is the sine function. The inside function is what you have inside of the sine. This is the argument for which you're taking the sine of, and it's 3 times x. Well, the derivative of 3x is 3. So my derivative of the inside portion is 3. So we know chain rule is derivative of the outside function times derivative of the inside function. And in this case, like my f is sine, the g of x part is the 3x. So based on the formula, it's f prime of g of x. Well, f prime, that's the derivative of the outside. That's derivative of sine, which is cosine. And then g of x, which is 3x, times g prime, which is the derivative of the inside. Derivative of 3x was 3, so it's times 3. And so we get y prime's equal to 3 times cosine 3x. All right, so that's an example where you're using the chain rule, and it's not necessarily using this general power rule. All right, in general, if you use a function of x, derivative of sine of u is equal to cosine u times u prime. All right, that's the general relationship. Now I'm going to go to the table on Blackboard, so this table of basic derivatives and integrals. And you'll notice that these derivatives have the letter u. So these are using the chain rule. So like right here, derivative of sine of u is cosine u times u prime. So that is why these have the letter u, because they're using direct application of the chain rule. All right, so that's where I'll stop it for this video. And then next video, I'm going to jump into a bunch of examples.